Hi students, under electric field we have one question here, that is define intensity of electric field at a point, derive an expression for the intensity due to a point charge. This may be asked for 4 marks in the examination. So what do you mean by electric field intensity? We have discussed in the previous classes. Electric field, it is an imaginary line where the charge creates its own field influence. It creates its own influence in the air, right? Now, the electric field intensity is defined as force experienced by a unit positive charge when placed at that point in a field. Suppose any charge q is present. If the charge q is present, around that charge some field will be generated. Either it is a positive charge or negative charge. So if unit positive test charge is placed in that, suppose if this is a charge q, okay, around this it creates its own field here. So in the range it creates its own field. When test charge q naught is placed in this field, then what happens? So either if this is a positive charge and test charge is always +1 and it is having positive polarity, and here somewhere one charge is present. Suppose if this is placed in this field, then what happens? This is positive and this is positive. Due to that it repels. Means it experiences some force. So that is electric field intensity. Force experienced by the unit positive charge placed at that point. So force experienced, electric field intensity is defined as force experienced by unit positive test charge placed at that point. I can say E is equal to electric field intensity is equal to F divided by Q naught. F divided by Q naught. So now, what was the question at a point? Derive an expression for the intensity due to a point charge. Suppose point charge we have to consider. Point charge means what? Suppose if this is a point Q, okay, at somewhere on the same line, suppose a point P, consider a point P, here test charge plus Q naught, I mean +1, Q naught charge is +1 at this point, at A, this is point A, and if this is point O, and if this is placed, point P is placed at a distance R from the charge Q. See, charge Q is having the polarity positive charge and the test charge is also having the polarity positive charge. Positive repels each other and the electric field will be in this direction. Electric field intensity will be in the outwards because this is positive charge and even this is also positive charge. Then what happens? E is equal to F divided by Q naught. We know that Coulomb's law, according to Coulomb's law, we know that F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square by Q naught, this is. Right? So now here Q1 is equal to capital Q. Here Q1 is equal to capital Q, Q2 is equal to Q naught. So substitute these values here. It becomes 1 by 4 pi epsilon naught, or I can write it as a K only. K is equal to 1 by 4 pi epsilon naught because K is equal to constant 1 by 4 pi epsilon naught, isn't it? K, Q1 is what? Capital Q. Q2 is what? Q naught divided by Q naught. So Q naught gets cancelled. E is equal to, here electric field E is equal to K capital Q. It means 1 by 4 pi epsilon naught. Okay, here R square is there. Q1, Q2. Q1 is capital Q. Q2 is Q naught and divided by R square is there. Here K Q by R square it is. And here 1 by 4 pi epsilon naught capital Q divided by R square. This is the expression for electric field intensity due to a point charge. I think you have understood this. When the test charge is placed near a charge, either it may be positive charge, either it may be a negative charge. If it is a negative charge, positive and negative gets attracted towards this charge. If this is positive and test charge is having always positive charge and it is having plus 1 value, so positive and positive, they will repel each other. See, whenever test charge, unit positive test charge is placed in a unit in the field, what happens? It experiences some kind of force. Either it may be a repulsion or it may be attraction. That is called as electric field intensity at that point. It is defined as force experienced by unit positive test charge placed at that point. The formula is electric field is equal to E is equal to F by Q naught. And what is the SI unit for this electric field intensity? Force is measured in terms of Newton and charge is measured in terms of Coulomb. So Newton per Coulomb. SI unit of electric field intensity is Newton per Coulomb. This is the SI unit. This is SI unit of electric field intensity. And you consider a charge Q placed at a point O, and on the same axial line consider a point P is placed at a distance R from the charge. At P, test charge plus Q naught is placed. This is positive charge and this is also positive charge. In between these two, repulsion will arise and electric field intensity will be outside because positive repulse each other. In this direction, field will be arising. We know that electric field intensity is equal to E is equal to F by Q naught. We know that Coulomb's law 1 by 4 pi epsilon naught Q1 Q2 by R square by Q naught as it is. Here from this given data, Q1 becomes capital Q, Q2 becomes plus Q naught. Then substitute these values here. K means 1 by 4 pi epsilon naught. Q1 is capital Q, Q2 is Q naught by R square whole divided by Q naught here. Q naught gets cancelled, it becomes KQ by R square or 1 by 4 pi epsilon naught Q by R square. This is the expression for electric field intensity due to a point charge, and the SI unit of this electric field intensity is Newton per Coulomb or volt per meter. Another unit we have for this, volt per meter. This is about electric field intensity. Thank you for watching this video.